The Bitcoin network is the backbone of the Bitcoin system. When you think about it, it is really needed and the foundation for the exchange of any information. So before we can talk about how transactions are verified, how blocks are assembled, and how you reach a consensus, we must understand how this information is exchanged. Alright, last time we talked about peer-to-peer networks in a general sense. And now this time we will look at how peer-to-peer networks are used in the Bitcoin network, how it is actually applied to Bitcoin. And most of the things will be quite familiar. I mean, it's quite similar to general peer-to-peer networks. Again, you have all of these connections, you have the network, and we will refer to any of these participants as nodes. A node being just one unit that is connected to other units in this network, that is exchanging information with everyone else. Okay, so it's basically one instance of the client software that runs somewhere. That's what we refer to as a node. Now, the way this happens also quite similarly to generalized peer-to-peer networks is you install your client on your computer, and then it sends out the version message to one of the addresses that come with the client, one of the initial IP addresses that are hard-coded in there, and the other node will send back a version acknowledged message, and that way you establish your first connection. Now, of course, this is somewhat controversial because when you think about it, when it comes with a list of addresses where you either have your first connection or where you can request some currently active addresses, that requires some trust. And of course, it adds some centralized component to it. Of course, you can always use a different IP address, so you can get an IP address from someone else and add it in there, so you don't have to actually trust that list. But at the end of the day, it's a matter of convenience. I mean, imagine if the Bitcoin client wouldn't come with this original list. How would you establish your first connection? How would you know where to connect to? I mean, there must be some form of initial setup, and that is with this hard-coded list. That is with these. Essentially, it's like a server that stores some of the addresses with potential peers to connect to. That's how you can think of. In any case, as I said, you send the version, get the version acknowledged back. So that's the handshake, the initial handshake where you establish the connection. Also, then if the other node also wants to connect, if you want to have a two-sided connection, then it will send you a version, you send back a version acknowledged message, and once this has happened, you have your first connection in the network. Now, one term you will always hear in this context is full node. A full node essentially is a node that has some core functionality and can verify everything on its own. Okay, when we're talking about a full node, that's a name for a fully autonomous node. So a node that doesn't have to rely on anyone else for getting and verifying. Well, for getting, of course, you connect to someone else and you get the information there, but you can verify everything on your own. Okay, that's the idea. So what is the core functionality of full nodes? First of all, you have a copy of a ledger. You have a copy of the entire blockchain. You have all the information stored on your computer. Second, you can verify everything on your own. So in this client implementation, you have software packages that allow you to verify all of the transactions, that allow you to verify all of the blocks. And of course, it does everything in the background. When I say allow you to verify everything, I'm talking about your machine that does that automatically. But it's your machine, it's locally, so you don't have to trust any external resources. And last but not least, this client allows you to relay the information, so basically contribute towards the spread of information throughout the network. So you can think of this last part, relaying, really as the information exchange. And that's also a core functionality of full nodes. Optional functionalities include wallets, so that's basically everything you need to issue new transactions, to create your own transaction, to spend your Bitcoin units. And mining, that's essentially everything you need to contribute towards the growth of the blockchain, so to make new proposals on estate updates and so on. And these are really optional functionalities that don't necessarily have to be in a client for it to be called a full node. Okay. So when we look at the various functionalities, then let's go with the copy of the ledger and the verification. Copy of the ledger is explained quite easily. I mean, you store the entire Bitcoin blockchain on your computer. It is part of the client. You have all the data there stored locally. And the verification basically allows you to, whenever you get a block, whenever you get individual transactions, you can easily verify whether they are legit. How exactly this is done, it was part of the cryptography series of this course. So we have various videos just on that. Stay tuned for that. We're not going to talk about that right now. So far, you only have to trust me. You really have to trust me that this is possible. And we will look later on how exactly it works. For example, when this person right here, when this node right here hands over a block, which is a collection of transactions, then this node right here can quite easily verify it. And in this case, it contains some invalid transactions. And here, right here, let's say this node has a collection of transactions that is valid. Also, the block itself is valid. Relays it, you get it, and then you can verify and you see everything is legit. And what will happen then is you add it to your local version of the blockchain. So you extend your local version, have added this block you just received and verified, and then you relay it to everyone else who's looking for it. So you basically provide this information to other peers in your network and contribute towards the propagation of the new information. Okay? And the way this is done is through various messages. So these messages, that's the form of communication in the network. That's how you exchange information. And the first message you have to be aware of is the get blocks message. The get blocks message basically takes an identifier of a block, a so-called hash value we will look at in the next lecture. And for now, just think of it as an identifier. And then you send this get blocks message with this identifier that refers to a specific block, and the other node receives it. And once they have received it, they can compare it to their most recent block. So you send the identifier of your most recent block, so the last block in your blockchain, the most current block in your blockchain. You take the identifier of that, send it with the get blocks message to someone else, and the other person compares it to their most recent. And now let's assume, for example, that this node right here has the most recent block with block height 1. Okay, and this person right here actually has two successors on top of that. So it has block 1, but there also is one successor that builds on top of block 1, which is called block 2, and then you have block 3. Okay, so when this node right here receives the get blocks message with the identifier of block 1, it knows that this node right here doesn't know about these two. Okay, so got the get blocks with the most recent block of this node right here, which was 1. Obviously, this node on the left doesn't have blocks 2 and 3. So what it does, it will send an inventory message saying, hey, I have more recent information than you. I know more than you do. I'll send you my inventory with the identification numbers with the hash values of block 2 and block 3, let's say. Okay. And then this person gets these identifiers and has the opportunity through get data to request the information. Now, get data takes the argument that we're talking about blocks. So first you specify that, and then you add the hash value of the block, and that way you can get the block, you can request it from someone. Okay. And the reason why it is done this way, which essentially is a pull option, so you're not pushing around information, you're actively asking for it, is to make sure that there isn't any redundancy. That way this person right here can distribute the workload and could potentially say, hey, I want to get block 2 and 3 from this guy and block 4 and 5 from this person. Now when you have a push system, then this person would just get overwhelmed with information and have a lot of redundancy in there. So it's just much more efficient if you actually pull it, because right here, the inventory and the get data, that's just with identifiers. So that's just the hash values that identify the blocks. Only with the block message itself, that's just when you actually send the information. Okay, and that's why it is more efficient. Now the reason why there is B1 to B500 in there in the inventory is because there is a cap. With the inventory message, you cannot send any more than 500 identification numbers, 500 block identifiers in this case. Of course, you can send multiple inventories and you can get them from various persons, so it doesn't really matter. Also, once you got the block data and you send another get blocks, then you might be closer to the current state of this node's information set, and then you might get an entirely different inventory message until you're called up, until you are in sync. Okay, so with transactions it works quite similarly. With individual transactions, again, you get an inventory with all of the transaction hashes, all of the transaction identifiers, and if there happen to be transactions in there you don't know about, then you can request the entire transaction with the get data, with an identifier parameter, and then the other node will send you the transaction information of the corresponding identifier. And that's easy as that then. So basically what you need to know is you mainly exchange two kinds of data. You exchange blocks, which are collections of transactions, and you exchange individual transactions. And you have to be aware that it's really a pull mechanism, so you're actively requesting the information you want. It's not just pushing around. The only thing you are pushing around are the identifiers, but then you have to actually actively ask for the information. So wallet functionality contains essentially three things. Number one is an encrypted key store. It's really important when you have private keys that allow you to access your funds that you don't have them in plain text form on your computer. That would be a really, really bad idea. So when you have them on your computer, they must at least be encrypted, and some of the client implementations will take care of that. Most of the client implementations, if you have really high security requirements, it might be a much better idea that your private keys never actually touch your computer, and that is usually referred to as cold storage. We will talk about that at a different time, but when you have it on your computer, then it must at least be encrypted. It's something your wallet, your client can take care of. Also part of the wallet functionality is some request for balances. So your client may give you an easy way to requesting balances for certain addresses. And that's also really important when you want to use it as your wallet, essentially. When you want to make payments, then you have to know how many Bitcoin units you own. And then, of course, you must be able to request your balances, and that's something you usually get with the wallet functionality. And then, of course, a good-looking general user interface, an easy-to-use general user interface, so that gives you an easy way, a straightforward way to interact with the blockchain and to issue new transactions. That's also part of the wallet functionality. That is, as I said earlier, optional and not part of the set of functions of a full node. It can be, but it doesn't have to be present for us to talk about a full node. Then the mining functionality, as I said, that's really the idea that you contribute towards the growth of the network. It lets you assemble new blocks, so it knows the rule set of how you, in what structure you have to assemble a block, what transactions can go in there, the limitations, and so on. And it also gives you everything you need software-wise to add some computational resources to it and contribute towards consensus. I don't want to go into too much detail here because we have an entire section just on Bitcoin mining and how it actually works. But essentially, just as a quick teaser, what you're doing is you're computing hash values over and over and over and over again. And this mining functionality actually allows you to do that on your computer. Of course, you still need the computational resources, but it allows you to manage these resources in a somewhat efficient way. Good. When we talk about nodes, there are two things you must be aware of. They are quite distributed. Of course, there are geographic areas where it's more dense, for example, Europe and the US. But in general, it's all over the world. So it's a good diversification all across the globe. Currently around 50% in Europe, 20% in the US. If you want to get more recent stats, if you want to be able to look at the geographic characteristics, but also what kind of clients they're using and so on, there is a really great website, a great data set on bitnodes.io, and the stats I present here are from March 2021. So when you watch this video at a later time, it's probably a good idea to look at these stats on the website. That's some historic data. In December 2013, we had approximately 15,500 full nodes. It dropped down significantly and went up again. The reason for the drop down, I mean, you can only speculate, but when you think about it, you don't have a direct incentive supposedly to run a full node. I mean, many people don't have a need for verifying it on their own. I think it's a big mistake. I think there are many benefits to running your own full node, but many people that just want to use Bitcoin as easy as possible. They want to have it on their cell phone, don't want to think about anything about it, and want to think about anything. Just they don't care when they have to trust anyone. They just want to use Bitcoin for whatever reason. Okay, and these people obviously don't run full nodes. So what's really important to understand is when we're talking about 10,200 full nodes in 2021, obviously these 10,000 people, that's not the total number of Bitcoin users. That's just the people who hold an entire copy of the blockchain, who verify everything, who have all this core functionality on their computer. And also, and that's also really important, these are just the advertised full nodes. There are many more that have not been reachable by these. It's essentially based on this data set right here. So only when the infrastructure from the person who compiled this data set is actually able to detect these full nodes, only then they will be in this data set. And of course, there are many more than that. So I quickly said, I think there are great reasons to run your own full node. Why am I saying that? I mean, there are costs, direct costs. You have to run a computer with the client software. It has to be always on for it to make sense. So there is some cost associated with it. Why do I say there are great incentives? And I think there are two great incentives. Number one, you're really independent. I mean, when you think about it, you have the entire data from the Bitcoin system on your personal computer. Your computer is verifying everything. Every single transaction gets verified on your computer. You don't have to trust anyone. You have all the data stored on there. You can you don't have to rely on anything else. You're not dependent on any information whatsoever. Everything you see is 100% mathematically verified by your own computer. And that's amazing, especially when you compare it to traditional financial systems where you have to trust so many centralized parties, where you cannot necessarily verify too much. Here you have all the information on your computer and you know for sure that everything matched out as promised. You can verify every single step, and that's just fascinating. Number two, this data set, this direct access to the data, might be really valuable. Now, of course, I'm biased. I'm a researcher. I work with this data and I'm fascinated by it. But also for companies, this might be really valuable when you have all the transactional data you can work with. And many of the analysis you might be interested in, you can only manage to do them when you store the data locally. And also, I mean, you want to be sure that everything you have is 100% accurate, and you can only guarantee that when you're running your own full node. So long story short, there are good reasons to run your own full node. Also for companies who are accepting Bitcoin, for example, they don't necessarily want to rely on some infrastructure provider to say them, yes, your payment has arrived. When they are running their own full node, they can verify that for themselves and they know it for sure. And then they can react to it with internal processes, for example, when they know 100% that something has happened. And this is fascinating, especially once you realize that the infrastructure you need for it is really, really, really small. You don't need a lot. I mean, you can essentially run full node infrastructure on a Raspberry Pi with some attached storage. It's really inexpensive. So on these tiny little computers that don't consume too much power, and you can run an entire full node that verifies all the information of the entire blockchain, which is amazing. And as you can see, I'm fascinated by it, and I encourage everyone to run one of these full nodes just as an educational experience. This will give you so many insights into the network, and you will get a great chance to actually look at this data, work with it, and get an understanding and appreciation for it that you otherwise wouldn't be able to get. So that being said, for most people, they don't really care about that. Most people, they just want to access the network somehow. When you talk to people, I mean, especially in Switzerland, so many people own Bitcoin with air quotes, but when you actually talk to them, what they own is some promise for delivery from a centralized service provider. So they either have cryptocurrencies on an exchange or some certificates on Bitcoin or anything in that direction. Okay, and then we are really here in the upper right corner. It's essentially a centralized network where they have the entire information they get just comes from one node, but even worse, they are not even in control of their own private keys, so they don't have access to their funds. The private keys are under the control of the centralized service provider, so for example under the control of the centralized exchange, and when this guy right here wants to have access to his Bitcoin units, he has to ask the centralized provider, so the exchange in this case, to issue a transaction. So he logs in with his username and his password to a website and says, hey, exchange, could you please issue a transaction on the Bitcoin network that transfers my Bitcoin units that are currently in custody with you to my account? Okay, and in many cases that's not even possible. So long story short, since these people right here, they are reliant information-wise on this centralized service provider, but also in terms of access to their funds, they are completely dependent. It doesn't have anything to do with this decentralized network anymore. Essentially, it's banking on top of Bitcoin, which might be fine for some people, and in some cases, if you're 100% sure that you can trust this service provider, well, then it will better be regulated and you better know who's behind it. But in many cases, it's highly dangerous. Also, I mean, when you think about it incentive-wise, when this custodian stores private keys for many different accounts and holds Bitcoin units on behalf of so many users, then essentially it becomes a honeypot for hackers. And that's why also throughout the history of Bitcoin, when media claims that Bitcoin has been hacked, it's usually the cases where the centralized exchanges that store private keys have been hacked, and the hacker was able to get access to these private keys and therefore to customer funds. So that's usually, it's not a good idea, and you have to know exactly what you're doing when you're trusting somebody with cryptocurrency custody. And another option would be that you are in possession of your own private keys. So you are creating your own private key, derive your public key from it, you have your Bitcoin address from it. So that you do that on your own, but you don't run a full node. So you get your information from one specific node, let's say, when you issue a transaction, you send that transaction to this one node. When you request information you need, for example, balances, then you get that information from this one node. And of course, it's some form of dependency also. Because your information set comes from this one node, and there are some wallets who are implemented that are implemented this way, and it's much better than this solution right here, because at least you are in possession of your own private keys, so you can access your Bitcoin units, but still you are reliant on the information set this one service provider gives you. And this could potentially be fraudulent, this could potentially be wrong. So there still is some form of dependency. But most people will access the Bitcoin network in one of these two ways. Now, I get it, especially when they are using mobile wallets. There are many reasons why they don't want to run a full node on their mobile devices. Think of storage capacity, for example. I mean, the entire blockchain takes up quite some storage, and that wouldn't fit on many of the cell phones, or would take up significant portions of your cell phone memory. And then the bandwidth, of course. I mean, yes, in Switzerland, many people have flat rates, but as I understand, that's not the case everywhere in the world, especially in the US. Not everyone has a flat rate, an internet flat rate. So this might be an issue. And then, of course, battery life. I mean, when you're constantly propagating these messages, when you're constantly verifying everything, even though your cell phone could handle it, actually, it would drain the battery. And as we all know, that's a big issue with cell phones anyway, so it's probably not a good idea to do that on your mobile device. So what you could do, of course, is using one of these two options. As I said, I don't necessarily think that it's a good option, especially this one is in most cases a really bad option, but there are some alternatives. And alternative one is a so-called SPV client, a simplified payment verification client. It's still a node, although a limited one, but instead of getting the entire information, instead of just requesting everything, instead of verifying everything, you have certain heuristics. For example, you only get the block headers that are essentially the identification numbers plus some meta information. And when you receive a transaction, and you want to verify what actually has happened, then all you're verifying is how many blocks, how many legit blocks have been built on top of the block that contains this transaction. And once this reaches a certain threshold, without having necessarily access to all the information, once it receives a certain threshold, you just assume that this transaction is valid, because someone else took so much effort in creating these new blocks on top of it that you can, with a certain probability, confidently say that it probably is legit. Okay, so it's a probabilistic process, even more so than when you're part of the entire network, but it gives you some ways of telling with a relatively high degree of certainty that something has happened. And that's called simplified payment verification. Again, the biggest differences are that you don't store the entire blockchain, that you don't request all the information, but you're still connected to the network. So you're still a node, you're still part of it, and you still can get, and that's in fact really important in terms of security, you still can get your information from various sources. So that's the biggest difference to this case right here, where you just connected to one information source. With simplified payment verification, you get the information from various nodes. The reason behind this is that when one of these nodes would be trying to cheat you, when one of these nodes would be trying to advertise, relay false information, then you would most likely get conflicting information from someone else and see that something is wrong. Okay, and then of course trusted nodes. Trusted nodes is a really simple concept. It essentially says, hey, why don't you just run a full node at home? Okay, on a Raspberry Pi, really inexpensively, and then you connect with your mobile wallet to this full node. And then you have the best of two worlds. On your mobile wallet, you don't have to store anything, you don't have to verify everything, but since you are connecting to a full node you can trust, you are connecting to your own full node at home, you know that you will get the actual information you have verified, your computer has verified mathematically in your personal network locally at home. Okay? So that's it. That's the introduction to the Bitcoin network, how the information is exchanged. Now I realize that this is highly theoretical and abstract so far when we talk about things like verification, and you haven't seen that. But I mean, we cannot tackle everything at once. Otherwise, you would have no chance of understanding it. So try to go with me, try to stay tuned and just take it step by step. And I promise it will start to make sense once we have covered all of these parts. But when you know that there's this network where you exchange information, that you have blocks and transactions that get exchanged on there, then you are good for now. Okay? So with that, stay curious. See you soon.